Hey everyone, welcome back to the channel. Hope you're having a great day today. Today I'm going to show you how to run a project called Krustlet on Azure Kubernetes Service. So for those that don't know, Krustlet is this new open source project we've been working on for the past few weeks that allows you to run WebAssembly workloads natively on Kubernetes. We just released version 0.10 earlier this month. We're still working on some of the design kinks around the project, but hopefully today what I want to show you is how to get started running with it today. And we can go from here and perhaps release more video tutorials as updates come along. So really what this is going to be is just kind of a moving tutorial where we'll start with what we have today in version 0.10, and perhaps we'll come out with new videos as updates come along and we have to update the documentation. All right, so let's dive into today's lesson. All right, so for today's lesson, we're going to look at running Crosslet on Azure Kubernetes Service. Now, in order to run Krustlet on Azure Kubernetes Service, we need to create an Azure Kubernetes Service cluster first. So inside of the Krustlet repository at Deus Labs Krustlet, there is a how-to section in the documentation that describes how to run Kubernetes on Azure Kubernetes Service. It's basically how to create a cluster. So the first thing we need to do is create that cluster. So there are two options to do this. The first one is through the command line. If you're like me, and it makes for a better video, of course, I'm going to do the web portal. So I'm going to go into the Azure portal, and I'm going to go through the whole step-by-step guide to creating a cluster. So the first thing we need to do, we're in our portal. We'll go and create a resource. We'll search the marketplace for Kubernetes. We'll hit create. So the first things I'm just going to ask you to do is, in a subscription, for me, I have my account here, and then I'm going to create a new resource group. So I'm going to call it Crosslet Demo. A resource group is basically a logical grouping of units inside of Kubernetes or inside of Azure, so we're able to install everything in the same resource group, and if we delete the resource group, everything else is deleted underneath it. So now we need to give it a Kubernetes cluster name. So we'll do Crosslet Demo. And then we'll choose a region that is relatively close to our location. So I'm based in the northwest of North America. So I'm going to choose US West 2 as my region. And then the Kubernetes version. So I'm going to use version 1.17.3, which is a preview version on AKS. It's the closest version that I have to kubectl on my terminal. So I could use the stable version if I wanted to, but for demonstration purposes, I'm going to use a more up-to-date version of Kubernetes. Then we have the node size and the node count for the cluster. So the standard VM size is going to be just fine for what we need it to. We're actually not even going to use these VMs in this demonstration. And we have 3 nodes, which is the default for a Kubernetes cluster. So we're going to go forward with that. The next page and every other preceding page is just kind of like some setups that you can add to it if you want. We're not really concerned about node pools. The default authentication is fine. The default networking is just great. Something to keep in mind here when you're going through this demonstration is that there's this possibility of connecting your AKS cluster with additional services, one of them being Azure Container Registry. For this demonstration, we're just going to use demos that were already in a public container registry to run WebAssembly modules in our cluster. However, if we were building our own modules and if we wanted to publish it to push to our Kubernetes cluster, we would need a container registry to publish those too. So I would highly recommend, if you're looking for actually creating a Kubernetes cluster, you'll want to create an Azure Container Registry. So I'm just going to throw that out there as a suggestion. What we're going to see in the end here is that it's going to create a new Crosslet Demo resource group. The cluster name is Crosslet Demo. And we're at Kubernetes version 1.17.3. And then we have all the default settings here for the node pools, the authentication, networking, and whatnot. So once it's finished here, we'll go and hit create. All right, so now it's initializing the deployment. It's going to create that Kubernetes cluster. It's going to take a couple of minutes, so I'll come back when it's finished. All right, so now we can see here that the Kubernetes service, the cluster, has now been created, is now in the succeeded status, and everything is set up the way we need it to. So now what we need to do is configure our kubectl that we have installed locally to actually point towards this cluster. So we need to use AKS get credentials. Now, if you've never used the AZ CLI before, the first thing you need to do after you install it is do an AZ login. And once you've done that, you'll be logged into the Azure CLI or to the Azure portal through your terminal. So what I can do here is do an AZ AKS get credentials. And then we'll give the name Crosslet demo. And the group name is Crosslet demo as well, as we did before. What this does is that it pulls down the configuration over to your kubeconfig, and now you can see there's a Crosslet demo as your current context in your kubeconfig. So now that's done, which is great. We now have a Kubernetes cluster, and if we do a kubectl cluster info, you can now see that we're pointing at that Azure cluster. So now we can go into the next step, which is actually running Crosslet on Azure Kubernetes Service. So the first thing is we require running AKS Cluster for this guide, as we've done before. But now we can go through the steps. So now we need to create a service account user for the node. By doing that, we can just copy and paste this whole blob right here, because I personally trust this content because I'm one of the core maintainers of Crosslet, but as always, don't always trust everything that's on the internet unless you've written it yourself. So make sure that you know and trust the content. But here we can see that the service account for Krustlet has been created. The cluster role binding has all been created for Crosslet. So that's all good. Now what we need to do is generate a kubeconfig with this service account. So we're going to actually do that. So we're going to do a curl for that shell script over here, which is again in Krustlet. Core maintainer, I trust this code. You might not have that same kind of trust profile, so make sure that you trust code that you run. And there we go. So what it did basically is that it used the service account that we just created in the last step, and it's now pointing our kubeconfig to use that context. So now we need to create a certificate. So we're going to go ahead and do that by copying and pasting this whole OpenSSL generation command. So now that created a private key for us for Krustlet. And now what we need to do when a kubelet communicates with Kubernetes, it needs to be able to have some form of authentication to say, yes, I am me and nobody else is me. And so how that authentication happens is through TLS certificates. So the Kubernetes API server has a certificate signing request over there, and it approves it, given the certificate sign request that we just created here in the last step. And what that's basically going to do is we're going to improve that certificate. And so anyone that authenticates with that TLS certificate is authenticated to use the Kubernetes API. So we're going to go here, and we're going to paste this. So now in Kubernetes, it now has the certificate signing request available in there. And now, because we're an administrator of the cluster, we're going to go ahead and approve that certificate sign request. And there we go. So now we can download the certificate from the Kubernetes API. So then Crosslet can talk to the API server. And then finally, what we need to do is combine that key and the certificate, the private key, as well as the certificate that was given to us by Kubernetes, and turn that into a PFX, because that's how the kubelet talks to itself. It's just a bundle, basically. So in the steps here, it says to choose your own password instead of password. For the sake of this demonstration, I'm just going to use password, but it's highly recommended, of course, that you change this as you need to do. There we go. So now we need to actually create and access a new virtual machine in the AKS cluster. So what that means basically is that we're going to create a new virtual machine inside of the same resource group where all the rest of the AKS nodes are sitting in. So what we're going to do here is we're going to run this command and give us that cluster name. So you can see here, it's not the same thing as Krustlet-demo, that resource group and that name. We're actually querying for a special resource group that is called the node resource group. And this is provisioned by Azure. So what we're going to do here is we will do an AZ AKS show the resource group, which is Crosslet demo. And then the name is Crosslet demo. And then we'll copy the rest of this here the query and the output format so we can parse that. So you can see that name is different than the Crosslet demo resource group. So we're going to export cluster resource group. There we go. So now we have the environment variable cluster resource group set there, so we can just use it and reference it from the rest, or for the rest of the commands. So we need the name of the virtual network in that resource group. The reason being is that we're going to have the VM join the virtual network. So then the Kubernetes API server and the Krustlet are in the same virtual network and they can communicate with each other. So the table output is a little bit munged here, but what you can see is that we have the name of the virtual network as AKS VNet 816.513.27. So we're going to use that in the future when we create the VM right here. So in this one, we do an AZVM create. The name is going to be Krustlet. The group is going to be the cluster resource group, which is that MC Krustlet demo one there. Ubuntu long-term service. The administrator's username is going to be Krustlet, so we can SSH into there using the Krustlet username. It's going to use our SSH key, the public key, so then we can pass that along and we can SSH to the cluster. And then we're just going to create a standard cluster or standard size. And use the virtual network and the subnet. So we're going to do exactly that. So we're going to copy all this over. And then we're going to change the VNet name to AKS VNet. All right, again, so now we're just going to be waiting for this VM to create. So I'll come back to you in a couple of minutes. All right, so the VM has been created here. We can see that we have a private IP address of 10.240.0.7. We're going to need that when we need to connect to the VM later on. The one thing to note here is that SSH is not enabled on the public IP address. In order to access this virtual machine, we need to actually connect to it from the virtual network. And how to do that, because it's connected to the Azure Kubernetes Service, we'll need to gain access into the Azure Kubernetes Service cluster. Now there's documentation available in the Azure docs to actually connect to a node inside of a Kubernetes cluster. So we'll go and do that there. So in this how-to guide, we have a link that says found here. And this is how to connect with SSH to an AKS cluster node for maintenance or troubleshooting. So we're going to need this because we want to install Crosslet on there. This is all creating the virtual machine itself and connecting to it. But we've done all this already. So we have the node not available, but it's inside the virtual network. So we need to create the SSH connection. So inside of here, we'll do this command. And what this does, it will run a pod inside of the Kubernetes cluster that we can use to connect to we can connect to it. So first things first, we'll run that command. Okay, and now we're connected. We are in a bash terminal inside of a pod in the Kubernetes cluster. So you can see here. So the next step is to update and install the OpenSSH client. So now the next step is to open a new terminal window not connected to your container to copy the private SSH key into the pod itself that we're using. So we're going to do that here. So we're going to open up a new terminal. This one is our local computer here. And then we're going to do a kubectl CP of our private SSH key. I have one already. And then we will run it into the AKS SSH pod and copy that over. So that's copied. And then from there, we'll need to change the file permissions of the private key so then we can actually use it, of course. So back in the pod itself. And now we'll actually connect to the virtual machine. Before we do that, however, in the how-to guide, we need to copy over some other assets, which is the PFX bundle as well as this service account that we created before. So we're going to do the same thing before. We're going to do a kubectl CP for those two things. Back to our other terminal. And then we're going to copy and paste this one. So now that's done. Now we need to return to the terminal in the pod and copy them to the new VM. So we're going to do that using this. And so now we're in the pod terminal. We need to change the private IP address to the one that we had before, which is 10.240.0.7. And then we'll say yes to the SSH authentication. And there we go. So we've copied them over to the Crosslet node that will eventually be there. So now we can actually SSH into there. So we'll do an SSH-I IDRSA, and then we'll do Crosslet at, it is 10.240.0.7. And now we're in the Crosslet node. So now we can go and install and configure Crosslet. So the first things first, we need to create the etc Crosslet directory. And then we need to move the PFX bundle as well as the service account into that etc Crosslet directory. Then we're going to install Crosslet. Because this is a Linux machine, this is Ubuntu LTS. So we're going to do a wget, pull that down. And then we're going to untar that. So to untar that, xzf, because it's a gzipped tarball. And then if we look in here, we'll see we have our license, our README, and then we have the Krustlet WASC, Krustlet WASI, and a lib directory. Now this lib directory is only present in version 0.10. In version 0.20, that should be embedded inside of the WASP provider. But for 0.10, we're going to copy that over into the same directory that we do for the WASI and the WASP directory. So what we can do is a sudo move the Krustlet-was star, so that's WASI and WASC in this directory, and then the lib directory, and we want to move those all to user local bin. So now we need to enable Crosslet as a systemd service. There's an example Crosslet service that you can either copy to the box, but it's probably easier to copy and paste it. So what we'll do is we'll take the Crosslet.service and we will take the raw URL, copy that, and then we'll wget that as well. So now we have the Crosslet service. So where we need to move this is into etc systemd system Crosslet service. So we can go sudo move Crosslet.service over to etc systemd system. And then once that's done, it says here to make sure to change the value of PFX password to the password you set for your certificate. We just used password for this demonstration, so we're okay there. Now we're going to enable and start Crosslet. So let's go back into our main terminal here. Now, when we did the earlier instructions, we changed and created a new service account, and that kind of munged our kubeconfig. So what we're going to do is we're going to grab the kubeconfig back from the Azure portal so then we can communicate with it again. And there we go. So if I do a kubectl apply here, this is the same URL as what's available here. It's just the master docs, WASI, hello world, rust, case.yaml. So we're going to apply that to the cluster, and then we're going to run a WebAssembly workload natively on Kubernetes. So there we go. A config map and a pod were both created in the cluster. And if we do a pod, if we do a kget config map, we get both. And we see that already the WASI workload has finished. It has an exit code of 0, so it succeeded. And that was in less than 8 seconds. So it pulled itself down from the container registry. It ran to completion and finished in a very, very short amount of time. It is blazingly fast. So let's actually check the logs of that workload. And you can see here, so we have, in this demonstration, we're showing that it can pull from both the standard out and standard error streams. We're pulling values from the configuration or from the config map. And then we are grabbing things from the downward API, some environment variables and whatnot, and arguments that were being passed to the WebAssembly workload. So just kind of demonstrating different things that can be done inside of the workload. But there's the demonstration for you. And we have a Crosslet node running on Kubernetes. All right, everyone, thanks for watching. Hope you liked this content. If you did, leave a thumbs up. If you didn't, leave a thumbs down and leave a comment on why you didn't like it or how I could improve. Thank you for watching, and we'll see you in the next one.